Let us discuss one more example on system of linear equations. The question is, investigate for what values of lambda and mu the system of simultaneous equations x plus y plus z is equal to 6, x plus 2y plus 3z equal to 10, x plus 2y plus lambda z is equal to mu have no solution, an infinite number of solution, and a unique solution. So in this example, two unknown quantities are given, which are lambda and mu. We discuss all three possible situations like that. If we have given system of linear equations, then there are three situations. Either they are parallel to each other. If they are parallel to each other, it means there is no solution. If they are overlapped to each other, then we will get infinite number of solution. And if they intersect only at one point, then we get unique solution. So in this example, for which values of lambda and mu, the system have no solution, infinite number of solution, and a unique solution. So let us start to solve the question. We have to investigate for what values of lambda and mu the system of simultaneous equations x plus y plus z equal to 6, x plus 2y plus 3z equal to 10, x plus 2y plus lambda z equal to mu have no solution, in an infinite number of solution, and unique solution. The system of simultaneous equations 1 can be written as in the matrix form. Ax is equal to b. A is equal to coefficient matrix of the system of linear equations. So what are the all coefficients of x, y, z of the first equation is 1, 1, 1. In second equation, 1, 2, 3. In third equation, 1, 2 lambda. And the constant matrix is 6, 10, and mu. Where A is coefficient matrix, B is variable matrix, X is variable matrix, and B is constant matrix. Let us consider the augmented matrix. Now, our aim is to convert this augmented matrix to its echelon form. And after converting echelon form, we have to check that what is the rank of A and rank of augmented matrix. So all three solutions, no solution, infinitely many solutions, and unique solution, this is based on what are the ranks of A, means coefficient matrix, and rank of augmented matrix. Now here, if you want to convert this matrix to its equivalent form, we have to ask the question, is A1 1? Yes, here A1 is 1. So with the help of this 1, we have to make this and this 0 by applying the operation R2 minus R1 and R3 minus R1. So the reduced matrix is, there is no change in the first row, and the second row will become like this. Let us do it, how it will convert it. So the second row is 1, 2, 3, and 10. First row is 1, 1, 1, 6. If we subtract it, 1 minus 1 is 0, 2 minus 1 is plus 1, 3 minus 1 is 2, and 10 minus 6 is 4. Thus, reduced our second row is 1, 0, 1, 2, 4. So this is the second row. Similarly, if we subtract third row, if we subtract first row by the third row, 1, 1, 1, 6, minus, 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 minus. 1 minus 1 is 0, 2 minus 1 is 1, lambda minus 1 is lambda minus 1, and mu minus 6. Third row is 0, 1, lambda minus 1, lambda minus mu minus 6. After applying these two row operations, now we have to move to A22. Here A22 is 1, yes, and A33 is also 1. So we want to make this 0. For this purpose, we apply R3 minus R2. If we apply R3 minus R2, then the reduced matrix will be 1, 1, 1, 6, 0, 1, 2, 4, and 0 minus 0 is 0, 1 minus 1 is 0, lambda minus 1 minus 2, lambda minus 1 minus 2, which is equal to lambda minus 3, and mu minus 6 minus 4, which is equal to mu minus 10. And this is A33. And since there is no any element below A33, so this is the echelon form of the given matrix. Now, we want to discuss about the all possible three conditions. Condition number 1, no solution. So if rank of A, which is not equal to rank of augmented matrix, then the system has no solution. Clearly, if the lambda minus 3 is 0, if lambda minus 3 is 0, and mu minus lambda is not equal to 0. If lambda minus 3 is 0, if lambda minus 3 is 0 means what? 1, 1, 1, 0, 1, 2, 0, 0, 0. If lambda minus 3 is 0, then the coefficient matrix will be 1, 1, 1, 0, 1, 2, and 0, 0, 0. At this condition, what is the rank of A? Rank of A will be 2 because there are only two non-zero rows. Similarly, if mu minus 10 is not equal to 0, if mu minus 10 is not equal to 0, lambda minus 3 is 0. So what is the rank of, so we can write down like this, 0, 1, 2, 4, 0, 0, 0. Suppose mu minus 10 is, for example, it is 1. For example, 1. Here, the rank of coefficient matrix is 2. But if we consider the whole matrix, so all three rows are non-zero. So at that time, the rank of augmented matrix is 3. Since the rank of coefficient matrix is 2, rank of augmented matrix is 3. So therefore, the system is not consistent. It means that there is no solution. If lambda minus 3 is 0, means lambda equal to 3, and mu minus 10 is not equal to 0, means mu is not equal to 10, then rank of A is 2, and rank of augmented matrix, which is equal to 3. Hence, the system of equation have no solution. So for which values of lambda and mu, the system has no solution? If lambda equal to 3 and mu is not equal to 10, except that for if lambda equal to 3, mu is not equal to 10, then the system has no solution. So this is the first answer of our question. For lambda equal to 3 and mu is not equal to 10, the system has no solution. Let us go to the second part. The second condition is and infinitely many solutions. So when we get the infinitely many solutions, if the system of linear equation is given, and if rank of coefficient matrix is equal to rank of augmented matrix, but which is less than the number of variables. Here number of variables are x, y, z, means 3 variables. So the rank of augmented matrix and rank of coefficient matrix both should be less than 3. Less than 3 means it may be 2 or 1. If lambda minus 3 is equal to 0 and mu minus 10 equal to 0, then the last two will become 0, 0, 0. And at that time, the rank of coefficient matrix is 2 because this lambda minus 3 becomes 0. So if we consider about this coefficient matrix, 1, 1, 1, 0, 1, 2, 0, 0, 0. Therefore, the rank of coefficient matrix is 2. If mu minus 10 is also 0, then the rank of augmented matrix is also 2. Clearly, if lambda minus 3 is 0, means lambda equal to 3, and mu minus 10 equal to 0, means mu is equal to 10, then rank of A is equal to 2, which is equal to rank of augmented matrix. Hence, the system of equations have infinitely many solutions if lambda equal to 3 and mu equal to 10. Now the third condition, unique solution. If rank of A, which is equal to rank of augmented matrix, which is equal to the number of variable, then the system has unique solution. So how we get the unique solution over here? Clearly, if lambda minus 3 is not equal to 0, lambda minus 3 is not equal to 0. For example, if we have this is 1, this is 1, it may be also 0. Mu minus 10 is also 0. If, for example, lambda minus 3 is 1, and if you want to find out the rank of coefficient matrix, the first row is non-zero, second row is also non-zero, third row is also 0, 0, 1, which is also non-zero. Therefore, the rank of coefficient matrix is 3. Now, similarly, if this is also 0, but if we consider the whole augmented matrix, row number 1 is non-zero, row number 2 is non-zero, row number 3 is also non-zero. Therefore, the rank of augmented matrix is also 3. So clearly here, rank of A, rank of augmented matrix doesn't depend upon the value of mu. It may be 0 or it may not be 0. So sometimes we do the mistake that lambda minus 3 is not equal to 0 and mu minus 10 is also not equal to 0. But here the value of mu doesn't depend, because if it is not equal to 0, ultimately the third row will be non-zero. Hence the system of equation has unique solution if lambda is not equal to 3 and mu can have any value. It may be also 10. Hence, we obtain the three types of solutions. No solution if lambda equal to 3, but mu minus 10 is not equal to 0. The system has no solution. If lambda equal to 3 and mu is equal to 10, the system has infinitely many solutions. And if lambda is not equal to 3, mu can have any value, the system has unique solution. So this is the answer of our question. Thank you.